glad you're with us on First Principles Daily, episode 26. It's July 1st, 2026. Today's question, what would this cost if you only paid for the atoms? Most collected recyclables cost more to sort than the raw materials they contain are worth, except for a few that already beat that floor. Picture a full ton of household recyclables rolling into a sorting plant. Inside that load sits perhaps $30 or $40 worth of aluminum that can be recovered, a few dollars more in glass cullet ready for reuse, and a handful of dollars in assorted plastics after they have been cleaned and turned into pellets. The facility then lays out roughly $200 to cover labor, energy, upkeep, and hauling away whatever cannot be sold. The difference between those two figures is why so much of what households carefully set aside still ends up buried instead of reused. First principles reasoning starts by asking what the atoms themselves would fetch if separation happened at no cost. Then follows exactly where the added expense piles up. That approach shows why aluminum already passes the economic test, while glass and most plastics fall short, and why simply gathering more material will not close the gap on its own. Single-stream collection spread across North America after 2000, letting people drop every recyclable into one bin. Participation climbed, yet the arriving stream carried food scraps, shards of glass tangled with paper, and plastics that never belonged in the system. Recovery plants added screens, magnets, eddy current devices, and optical readers, yet human pickers still stand at several stations because contamination often tops 15%. Each extra touch adds wages and slows the whole line. Commodity markets swing sharply, so when prices for new resin or glass drop, buyers reject even slightly dirty loads and the plant pays landfill fees instead. Rules that count any recovered content toward mandates push facilities to keep accepting low-value items whose sale price never covers the work required. The headline recovery numbers therefore hide ongoing support from city budgets, and the whole business stays tied to the price of virgin materials rather than any built-in advantage of reuse. Some argue that keeping material out of landfills supplies enough public benefit to justify the support, yet that view leaves the physical cost of cleaning and moving the atoms untouched. Others expect rising landfill charges to flip the economics, but those charges sit on top of an already negative margin for most streams. The pattern holds because every player focuses on the visible collection rate rather than the hidden value of the raw materials. Take one representative ton of single-stream residential material. A rough magic wand estimate begins with the market prices of its main pieces. Aluminum near $1,500 for each ton of recovered metal. Clear glass cullet near $40. PET and HDPE together near $200 once turned into pellets. And the leftover mixed plastics near zero or below zero after cleaning and residue handling. Weighting those values by how much of each fraction usually appears produces a blended raw material floor on the order of $60 to $90 for each ton that arrives. Current delivered costs for the separated streams run several times higher once collection, sorting, and residue handling enter the picture. The overall idiot index therefore lands between 3 and 5, yet the number splits sharply by material. Aluminum sits near 1 because its sale price already covers sorting, while glass and most plastics sit above 10. The extra expense appears in 3 clear stages. Manual and optical separation work adds roughly $80 for each ton processed. Washing the dirty streams with energy and water adds another $30 to $40. Moving and disposing of the 15 to 25% residue fraction adds still more. Because every one of those steps happens before any sale, net revenue from glass and plastic portions often turns negative, which is why plants increasingly send them to landfills when virgin prices are weak. Consider a bale of mixed PET and HDPE that sells for $200 after sorting. Reaching market purity may have required $150 in upstream labor and energy, leaving too little margin to recover collection or capital costs. Faster optical sorters may trim the labor line, yet the sensors still face the same variability from food residue and label glue that no present machine removes without extra washing energy. The mismatch is therefore built into the process itself rather than waiting for one more piece of equipment. A redesign would start by cutting the contamination that drives labor and residue expenses. Packaging made from fewer resin types and fitted with labels that peel away cleanly would let optical readers reach higher purity without hand sorting. Deposit return programs for drinks already show that pulling mixed streams out at the point of sale can halve sorting expense while supplying cleaner aluminum and PET. Robotic picking guided by vision systems is moving forward, but its numbers still need steady, low-variety input. Policy that set recycled content rules only for materials whose recovered value exceeds sorting cost would direct spending toward aluminum, steel, and a narrow group of rigid plastics instead of spreading support across every resin. The remaining hard limit is the scattered geography of collection. Hauling low-density bales long distances eats margins unless regional pre-processing hubs sit near manufacturing sites. None of these steps needs new physics, only better alignment between how products are made, how they are gathered, and the actual commodity prices. The goal is an industry whose numbers no longer rely on outside support once the idiot index for each material drops below 2. Consumers sometimes resist shifts in familiar packaging, yet the same resistance once met returnable glass bottles and faded once deposit rules matched behavior to recovery economics. Earlier global trade in waste once hid domestic costs, but tighter import rules have simply made the mismatch between sorting expense and material value impossible to ignore. When the price of separating a material exceeds the value of the atoms it contains, the activity is performing economic theater rather than resource recovery. Redesign must therefore begin with the commodity price list, not with collection targets, because only materials that already clear their own sorting cost can scale without perpetual subsidy. The first concrete signal that someone is applying this logic will be a packaging redesign that eliminates one entire resin family from household streams while publishing the resulting change in net processing cost per ton. That's a wrap on today's first principles breakdown. The ideas travel further when you pass them on. Send this to a fellow builder. I'm Patrick in Vancouver. See you tomorrow. And if you'd rather watch than listen, find us on YouTube at Nerra Network. Links in the show notes. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own. I'm about to